So everyone, hi. So hope yesterday's workshop was great. You enjoyed it. So do you have um, any questions? Everyone's okay. So this time we have another set of great professors going to talk to you today.
Yes,
Hi, good
let
morning,
me.
madam. Can I ask one question which I have?
Sure, please go ahead.
Viscosity in transport properties. So if I have a computational domain where I have like two fluids mixing, and each of the fluids I know the individual viscosity, and then there is a viscosity in that like a transport property. So what is the difference between these two? Like, I'm a little confused. I hope you understood my question.
So see, if you have two fluids, you would typically move into a multi-phase solver in OpenFOAM, and you would have the ability to set the viscosity for each of these fluids. If that is your question, right? If that's not your question, then you'll have to repeat and I have to try and understand.
Like I'm just considering a computational domain where like a fluid is like there is an inlet in which a fluid is entering the computational domain.
Okay.
Let us assume that we only have like maybe one fluid stream, just to forget about this multi-phase flows. So, and I know the viscosity of the fluid, like the properties.
Yes.
Like pressure, temperature, velocity. And in the computational domain, in like yesterday's tutorial, there was a viscosity which was there. And when I asked that question, someone replied that it is the viscosity of the fluid in the computational domain. So when is that something that we input from our side, or like should it be equal to the viscosity of the fluid entering the computational domain? That's what my question is. Like, I'm a little confused.
Okay, so see, you have a computational domain, right? So let me assume that you have a pipe and you have fluid coming in, correct? So as far as the CFD is concerned, the initial, so you will have a CFD simulation where you'll have to start from t is equal to 0, time is equal to 0, and to up to a certain time, you will be simulating this flow through a pipe. So at t is equal to 0, at the inlet, you presume that water is coming in, correct? Now at t is equal to 0 in a CFD simulation, what you also do is you assume that water is still in the pipe already, okay? So there is an initial condition that is always set inside the domain, and then you set an initial inlet condition, right? So there are two aspects. So since you already presume water to be there inside the pipe, okay, inside the computational domain, it's not like it's an empty pipe, okay? It's having water already, you would set the viscosity same as that of the fluid. What you do through the simulation is you try to run it till the velocity profile inside the domain stabilizes. Does that make sense to you?
Yes, ma'am. So like as a follow-up, suppose if I want to increase the Reynolds number by decreasing the viscosity of the fluid.
Okay.
So what should I vary? Should I vary this transport property?
Okay. So typically when you're doing single phase flows, you're operating on a single fluid, which has a particular viscosity. It comes with a particular viscosity, right? So when you want to change the Reynolds number, if you're changing the viscosity, you're changing the fluid, or you're changing the temperature at which it's operating, if it's temperature dependent. Do you understand what I'm saying? So if you're running it for a particular temperature and you have a particular fluid going in and you want to increase a Reynolds number, you typically would increase the flux which is going in. If you want to increase the Reynolds number, you will increase the flux. So what I'll do is at the inlet, I will set a time-based inlet condition where for the first few seconds, it's a lower flux, and then I will increase the flux to a higher Reynolds number. flux. You get what I'm saying? So the fluid remains the same essentially. Okay. Now, if you are operating with a different fluid, say first few minutes, one particular fluid is going through, and then after some 1 hour, another fluid is going in, then additionally, you will have to accordingly set the boundary condition. Now, internal condition, you'll have to deal with the numerics very carefully, because after 1 hour, if the fluid is going to change, then what will happen is there'll be a viscosity variation between the two fluids inside. So that means I'll have to do a multi-phase flow at that particular point with two fluids filling in, and then a single phase flow. Does that make sense?
I did not understand it fully, ma'am. Yeah, my objective was to look at the effect of, like, increasing the Reynolds number by increasing the pressure and decreasing the viscosity.
Okay.
So I was a little confused. What should I change if I'm looking at?
So you will have to look at, so there is an option in OpenFOAM where you can give viscosity not as a constant, but as a variable property with respect to temperature or whatever expression you might have. Okay, so you can give a polynomial. So as your system changes, for example, I have done a simulation with variable viscosity with respect to temperature, right? So then in the viscosity situation, what I'll do is I'll give a polynomial in terms of temperature dependence. So as my fluid is getting hotter, then accordingly the viscosity will change basis the temperature it sees. So you can explore options where you can input a table with different parameters, viscosity changing with temperature. Typically, viscosity changing is more stable with temperature. Okay. I've not tried pressure-based variations. I don't know. I think it will make your solver a little bit unstable.
Yeah, like another way to ask, like we have, suppose in yesterday's example, the viscosity value, if I remember correctly, it was 0.01. If I change it to 0.005,
yeah, but then
and then run the simulation, what exactly is happening?
Nothing is going to happen. You're just saying that another fluid is coming in. That's all, right? So it's going to presume that the internal domain, it's going to just, so if you're doing it with water, say the simulation, and then you make it to oil, changing the viscosity, then it will just presume that the entire simulation is oil. You understand what I'm saying? So you just change viscosity, that means it's a whole new fluid. The domain will think that it's dealing with a whole new fluid.
Okay. Now I understood, man. Thank you.
Okay.